Hey guys, today we're going to start a new chapter on trigonometry. A lot of this, especially in this first section, is review because we did most of this last year in Math 2. We are going to review the Pythagorean theorem, special right triangles, and reciprocal ratios. And then our next section, we'll be looking at finding sides and angles using SOHCAHTOA. So as we look here at the Pythagorean theorem, we are going to find the missing side, and it's a good idea to always make sure you know which one is your hypotenuse. That way you'll know which one should be c squared and by itself. So 4 squared plus 8 squared equals x squared. So x squared is 80. And when we break down 80, the biggest perfect square that goes into 80 is 16. So that will be 4 square roots of 5. And then as we look over here at problem number 2, and notice it says give your answer in simplest radical form. That lets you know that you're not going to be using your calculator to get your answer. So x squared plus 22 squared is equal to 24 squared. And so x squared is going to be 92. And we're going to break 92 down as the square root of 4 times the square root of 23, which is 2 square roots of 23. Now, I want you to take a look at your special right triangles here. I'm going to pause this for a minute and let you guys study that for just a second. All right, so what you should see here that I really want to make sure that you are aware of is that in a 45, 45, 90 right triangle, your legs are the same and your hypotenuse is the leg times the square root of 2. And then in a 30, 60, 90, opposite the 30 is x, the hypotenuse is 2x, and then opposite the 60 is x squared root of 3. I do vaguely remember us studying special right triangles, and you guys didn't like those very much, but we're going to go ahead and review those here, and hopefully we'll remember them a little bit better. So y is going to be my hypotenuse. So x is going to be 10, and y is going to be 10 square roots of 2. And then when you have the hypotenuse, you have to divide by the square root of 2 to get your x. So that's 16 square roots of 2 over 2, which is 2 square roots of 2. So each of these will be 2 square roots of 2. I did that completely wrong. This is 2, and this is 8. Sorry about that. Square root of 2 times 2 is 2. So 2 goes into 16 8 times. I had my answer right first. I just didn't have it written down right. All right. 14 square root of 2 for your hypotenuse, which means divide by the square root of 2 to get x and y. So 14 square root of 2 divided by the square root of 2 is just 14. And now we're going to look at 30, 60, 90. If the hypotenuse is 8, 8 divided by 2 is going to be opposite the 30. And then the small side times the square root of 3 will be opposite the 60. So for number 7, 27 is equal to x square roots of 3. So divide by the square root of 3. See if we can do this right this time, or if I can do it right this time. 27 square root of 3 over 3 is 9 square roots of 3. And 9 square roots of 3 is going to be your smaller side, which is y. And then multiply that by 2 to get your hypotenuse. Again, I'm going through these quickly. We did all this last year. If you have any questions, let me know. Opposite the 30 is 5 square roots of 6. So your hypotenuse is going to be 10 square roots of 6. And then we're going to have 5 square roots of 6 times the square root of 3, which is 5 square roots of 18. 18, 3 square roots of 2, so that would be 15 square roots of 2. Again, all of that is review. If there's something that you have questions on, just make sure that you make a note of it. I've written a couple of things for you here. Now we're going to start trig, and again, you did all of this in Math 2. SOHCAHTOA for right triangles, sine is opposite over hypotenuse, which in this case would be a over c. Cosine adjacent over hypotenuse b over c, tangent opposite over adjacent a over b. A trig function is a function whose rule is defined by a trig ratio. A trig ratio compares the lengths of two sides of the triangle. The Greek letter theta is used to represent the measure of an acute angle in a right triangle. Now, reciprocal functions. Cosecant is the reciprocal of sine, so you just flip the fraction. Secant is the reciprocal of cosine, flip the fraction. Cotangent is the reciprocal of tangent, flip the fraction. So looking at number 9, find all 6 trig ratios for theta. So before we do that, we need to do the Pythagorean theorem to find the hypotenuse. And we'll just call that x. And 16 squared plus 30 squared and square root gives you 34. And if you notice, all 3 sides have a GCF. If you take care of that now by dividing them all by 2, when you go to do your trig ratios, you don't have to simplify. So that's kind of a little trick there. So here's your hypotenuse. So we're going to use SOHCAHTOA. So sine of theta is opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse. Tangent is opposite over adjacent. Notice the reciprocals are lined up beside their trig function, so you just flip the fractions. Cosecant, secant, and cotangent. For number 10, given the ratio for cosine, find the remaining ratios. Well, first of all, if cosine is 2/3, secant is 3/2, so 2 out of your 6 are complete already. So what we want to do now is label cosine as adjacent over hypotenuse, and then use Pythagorean theorem to find the missing side. So 2 squared plus x squared equals 3 squared. 3 squared minus 2 squared, square root of 5 is opposite theta. So sine is going to be square root of 5 over 3, and tangent is going to be square root of 5 over 2. Now, when you flip it, remember top times bottom over bottom with no radical. So 3 over the square root of 5. 3 over the square root of 5 is what you get when you flip it. Top times bottom over bottom with no radical. Top times bottom over bottom with no radical. Flip. Top times bottom over bottom with no radical. We're going to look at trig ratios of special angles, and if you guys will recall when we did our unit circle, these values will line up with your unit circle as well. So sine of 45 degrees is opposite over hypotenuse, which is 1 over the square root of 2, which is square root of 2 over 2. That'll be on your unit circle. Cosine of 45 is going to be the same thing, because the sides are the same. And then tangent is x over x, which is 1. For sine of 30 is x over 2x, which is 1/2. Cosine of 30 is x square root of 3 over 2x, which is square root of 3 over 2. And tangent is x over x square roots of 3, which is 1 over square root of 3, which is square root of 3 over 3. Top times bottom over bottom with no radical. And sine of 60 is x square root 3 over 2x, square root of 3 over 2. And cosine is x over 2x, 1/2. And tangent is x square root 3 over x, which is square root 3. So this concludes our section on Intro to Trig with a lot of review. We're going to be doing finding sides and angles next. You guys let me know if you have any questions, and have a great day.